All right, this is Mr. Gillum, and today we're going to continue to work with quadrants, as well as we're going to graph some coordinates that have fractional parts. And so the first thing we're going to talk about is what we call a reflection. It's a type of transformation. It's a fancy word, transformation, but specifically this type of transformation is a reflection. And a reflection is just when you mirror something. So you've heard this in Disney movies and things like that. When you see the reflection in the water, you see whatever is on the other side of the water. Or when you look in the mirror, it's a reflection. So there's two main types of reflections that we're going to cover, and that is over the x-axis and over the y-axis. Now, remember, the x-axis is the horizontal axis. And so what we do is we call wherever it's being reflected over the line of symmetry. This would be the line of symmetry because it is symmetric on both sides of the line. It could be folded over and land right on top of itself. So what I want to look at here is this line of symmetry. If I'm reflecting over the x-axis, I notice that this point is 1 away from the line of symmetry, or the x-axis, and this point is 1 away. It has the same distance away. And I notice that for every point. This point is 1, 2, 3 away, and this point is 1, 2, 3 away. They're a perfect reflection, the same distance over the line of symmetry. As you can see for this as well, 1, 2, 3 away, 1, 2, 3 away. These points are reflected. And finally, this point is exactly 1 away, and this point is exactly 1 away. So over the x-axis, and when it's reflected, it just means it's the same distance from that line of symmetry. In this case, the line of symmetry would be the x-axis. In the second example here, the line of symmetry would be the y-axis. Okay, y-axis is the line of symmetry. All right, and so that was kind of a bad, missed my mark there a little bit. What you can see is the same thing though. If this is the line of symmetry, I notice that this point is exactly 1 away, and this point is exactly, is exactly 2 away, and this point is exactly 2 away. They are reflected over the y-axis, the vertical axis. This point is exactly 2 away, as well as this point is exactly 2 away. They are reflected over the y-axis. And this point is 1, 2, 3, 4, 5 away, and this point is also 5 away. So you can see that they're reflected, and the y-axis is the vertical axis, so that would be your line of symmetry. Okay, so reflections, and so it's really helpful when you have a visual for your reflections. So your whiteboards in particular, I know, have grids on them, so it'll help you to figure out solutions when you sketch them on the grids. So if I am looking to reflect over the x-axis, I'm going to use a different color for each point. We'll do the 3, 5 in red, and the -2, 4 in green, and the -1, -5 in blue. And so we'll start with our red one. And we have 1, 2, 3 in the x direction. Remember, this is always x and y. So we're going to go 3 in the x direction. And so 1, 2, 3. And we're going to go 5 in the y direction. 2, 3, 4, 5, and I know it doesn't say positive, but if there's no sign in front, we know that they are positive. And so like a multiplication chart, we're just going to follow to where that point is, and I'm going to put that point right there. Okay, that is the point 3, 5. What we need to do is reflect that point over the x-axis. So before I do anything, I need to know how far away it is from the x-axis. The x-axis, here's my line of symmetry. And so let's see how far away from the x-axis this point is. 1, 2, 3, 4, 5. So I need to go 5 more past the line of symmetry. 1, 2, 3, 4, 5. That is where its reflected point would be. They're the same exact distance from the line of symmetry. So this coordinate would have the coordinates 3, -5. We went down 5 on the y-axis. All right, so its reflected point would be, 3, -5. Okay, and it's going to be important that we write that point down because I'm going to show you something that always happens. So for the green, we're going to go -2 on the x-axis, and we're going to go +4 on the y-axis. And so, like my multiplication chart. I'm going to make sure that my point is right where it needs to be at negative 2, 4. That looks good. Negative 2, 4. Right there. And I need to know where its reflective point would be over the x-axis. So over this. So let's find 1, 2, 3, 4 away. So I'm going to go 1, 2, 3, 4 more. That would be its reflected point if it were reflected over the x-axis. Okay, and its coordinates would be negative 2, negative 4. Okay, so it's supposed to be negative 2, negative 4. And finally, the blue one, negative 1, negative 5. Negative 1 in the x direction, negative 5, 1, 2, 3, 4, 5 in the y direction. There's the initial point. We need to figure out how far it is from the x-axis. 1, 2, 3, 4, 5. So we need to go 5 more. 1, 2, 3, 4, 5. There's the reflected point. And it's in a position at negative 1, positive 5. And so hopefully you're starting to see a pattern here when we're reflecting over the x-axis. I noticed that when I compare 3, 5 to 3, negative 5, the y-coordinate is now its opposite. And then when I compare negative 2, 4 to negative 2, negative 4, the y-coordinate is now the opposite. And when I compare negative 1, negative 5 to negative 1, 5, the y-coordinate is now the opposite. So let's just make a little note here. The y-coordinate is the opposite when reflecting over the x-axis. Find some place to write there. That's an important idea. When you're reflecting over the x-axis, the y-coordinate is its opposite. Let's take a look at the next one here, and this time we're going to reflect over the y-axis. So again, I'm going to go a little quicker this time because I think we know how to graph our points. And we're going to use different colors again, but I want to make sure that we understand we're doing the y-axis now, which is the vertical axis. So this is my line of symmetry for these 3 points. Let's start with the red one at 3, 5. So over 3 and up 5. Here is the initial point. We need to find how far from the y-axis it is. 1, 2, 3. It's a distance of 3. So we need to go 1, 2, 3 more farther. Its reflected point would be right there at the coordinate negative 3, positive 5. Okay, so negative 3, 5 would be my reflection. And then, if we look at the green one, we go back 2 and up 4. 1, 2, 3, 4. There's my initial point. We need to reflect over the y-axis, so I'm going to go 1, 2, and 1, 2. This is the reflected point here at the coordinates 2, 4. And finally, the blue, negative 1, negative 5. Back 1, down 5. That's my initial point, and it is only 1 away from the y-axis, so I need to go 1 more farther, and that is the point 1, negative 5. So when I reflect over the y-axis, what I notice is from 3, 5 to negative 3, 5, the x-coordinate has changed to its opposite. Same way on this one. The x-coordinate has changed to its opposite, and it went from negative 1 to positive 1. So when reflecting over the y-axis, the x-coordinate is its opposite. Find some space to write that down, because that might be a good shortcut for you to remember. All right. Just a couple more things here, and I've got this nice looking graph on the board, but what we're going to do is we're going to graph some fractions. And so this kind of goes back to when we were modeling fractions. Because it's in fourths for the first problem, what I'm going to do is I'm going to think of each line as being 1/4. So 1, 2, 3, that's actually going to be 1, and I'll label it right there. 2, 3, 4, and that will be 2. So I'm just dividing my graphs into fourths instead of each one being worth a whole. There's negative 1, negative 2. There's negative 1, and -2. Okay, and so it'll be up to you, and on your study island assignment, I know it will be already divided for you, but we're just dividing the graph. Instead of each line being a whole, we're dividing it into each line being 1/4. So if we're looking at a positive 1/4, we would be going in the positive x direction first, over 1/4, and then up 3/4. 1, 2, 3. That would be the positioning of the coordinate 1/4, 3/4. So more than anything, what we're doing is we're just changing the scale of our graph. Okay. The second one here has two fractional parts, a thirds. One is in thirds and one is in sixths. Now it's going to be much easier if I think about this as -4/6 and 5/6, because now they have the same fractional part. And so what I would do is I would use my understanding of equivalent fractions to make them have the same denominator, so I knew how much to divide each part up into. So now that it's -4/6 and then 5/6, I'm going to divide these into sixths. So every 6 is a whole. So there's 1, 1, 2, 3, 4, 5, 6. There's 1. 1, 2, 3, 4, 5, 6. There's 1. And 1, 2, 3, 4, 5, 6. There's 1. Okay, so each of these little rectangles now doesn't represent a whole anymore. It represents a sixth. So if I want to go in the x direction first, -4/6, I would go 1, 2, 3, 4 back, and 5/6 in the positive direction, up 5. That is the position of the blue coordinate right here, up in space. So we're just really changing the scale of the graph. And now I'm going to go ahead and erase that too so I have room. We're going to do this last one over here. And again, I noticed that we have 1.5 and -2 1/4. I like to think of them better as improper fractions. So 2 times 1 plus 1 is 3/2, and -9/4, like so. It's a really ugly looking 9. -9/4. 4 times 2 is 8 plus 1 is 9, -9/4. And again, I want them to have the same denominator, so instead of 3/2, I know 6/4 is the same thing, and -9/4. And so again, I'm going to divide my graph into fourths. So 1, 2, 3, 4, there's 1. 1, 2, 3, 4, there's 2. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. 1, 2, 3, 4. Sound like a dance instructor. Okay, so there we go. We now have it on there, up to scale. So now I want to move 6 1/4 pieces. So I'm going to move in the positive direction 1, 2, 3, 4, 5, 6 right here, and I'm going to move down 9 1/4 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. So where that point is the coordinate 6/4, -9/4, formerly known as 1.5, -2 and 1/4. All right, so that's how we're going to graph those fractional parts. Last thing I want to say is sometimes in your study island you might see some decimals instead of fractions. These would be a good reminder to you of some of the most common decimals that we talk about. 1/4 is the same as 0.25. 1/2 is 0.5. 3/4 is 0.75. And then fifths move up by 2/10 each time. So 1/5 would be 2/10, 2/5, 4, 6, 8, and so on. So if you see those decimals, it's very similar to what we were working on before. Same exact thing. So that's it for today. Hopefully you can graph those fractions on the coordinate plane, as well as identify those quadrants and know how to do some reflections.